Hello and welcome to Extracting Metals. We are in Measuring Change in the Geosphere unit. Okay, we're going to talk about mining and extraction using reduction, using electrolysis, environmental impacts. And for some of it, especially when we're talking about reduction, it's going to be a review for some of you. But it's good because it helps you to see how, so you learned about the chemical concept of reduction, and now you're going to see how people use it in industry. Okay, so metal extraction is a very large and important industry in the developed and developing worlds. So what positive and negative impacts can you think of? Obviously, we use the metals in a wide variety of applications, but it does have, which have positive impacts, but there are also a lot of negative impacts associated. Okay, so why do we extract metals? Most metals are found in the Earth's crust, combined with other elements, and this is called an ore. And it's really important that you understand that. So a metal combined with other elements in a rock are called ores. So for example, iron, which we use widely, is found combined with oxygen in ores called hematite and magnetite. Okay, and these are ores that Cambridge expects you to know. So on a Cambridge exam, it is fully possible that they're going to say, what metal are we going to extract from the ore hematite? And you need to know that it's iron, okay? Same as magnetite. So metals need to be extracted from ores before they can be turned into useful products like cars or cutlery. And the extraction of metals and minerals is the 5th largest industry in the world. The South African mining industry alone employs 800,000 people. So how is chemistry important to this industry? So mining for ores is expensive, and so it's only carried out where minerals are abundant enough for this to be profitable. So in industry, an ore is a rock that contains enough metal to make mining and extraction economical. And that's important to understand as well, that a lot of mines or a lot of rocks that you might find in particular areas might be ores. They might contain copper or iron or aluminum or another metal. But if it's not enough, if it's not a high percentage of metal in that rock, then it's not financially viable for us to extract it. So the value of ores changes over time due to society and technology. For example, rocks that contain only 5% copper would have been considered unprofitable in the 19th century, but today most copper comes from ores containing 0.4 to 1% copper. So extraction methods vary for different metals. Gold and some other unreactive metals like platinum occur native, and that means that they're found in the ground uncombined with other elements and really don't require, in a lot of circumstances, further extraction. Most metals are found combined with other elements as compounds and ores. And so these metals do need to be separated from the other elements that they're combined with. And many times, people in industry use chemical reactions to separate these metals from their ores. And really, there are two main ways of extracting metals this way. So there are burning ores with carbon, and this is called reduction, or electrolysis. And we're going to talk about both of these methods over the next few lectures. So how do mining companies decide which one to use? So really this comes down to a reactivity series. The reactivity of a metal will determine how people extract it. So when you're looking at these metals, you place them in order of increasing reactivity. So platinum, gold, silver, and copper often occur in their native form, in other words, not in an ore with other elements, and they generally do not need to be extracted. Okay, you can see hydrogen in there. And then next, lead, iron, and zinc. These metals are less reactive than carbon, so they can be extracted from their ores by reduction using carbon, coke, or charcoal, and we'll go through that process. Okay, aluminum, magnesium, calcium, sodium, and potassium. These are metals above carbon in the reactivity series, and because they are more reactive than carbon, then they must be extracted using electrolysis. And electrolysis can also be used to purify copper, which is something that Cambridge often asks you about, and we will go through that process in detail. You will also be performing the electrolysis of copper in lab in the next couple weeks. Okay, so you do need to know this reactivity series. I have another lecture where we're going to talk about it, but you do need to memorize the order of this. And when you're in class, I encourage you to get out a periodic table and look at where these elements are on the periodic table, because their position in the table has everything to do with their reactivity. Okay, and we'll talk about that. Okay, so let's talk about specifically extracting ores from oxides using reduction. So given that metals are often found combined with oxygen as oxides, to obtain that metal, the oxygen has to be removed. And the removal of oxygen from a substance is called reduction, okay? So remember that reduction, oil rig, reduction is gaining electrons, so that's losing oxygen, right? Because oxygen is an electron hog. So when you lose oxygen, okay, you are gaining more of your electrons back, and so that's reduction there. So metal oxide in an ore goes through reduction to yield the metal. Okay, so carbon can be used to extract metals by reduction if those metals are less reactive than carbon. So if you take lead oxide, for example, and heat with carbon, you will get lead in its pure form plus carbon monoxide. And in this reaction, the carbon is removing oxygen from that lead oxide from that ore. So this occurs because carbon is more reactive than lead. And that's what it all comes back to, because remember, in these chemical reactions, whichever one of them is more reactive is the one that's going to take oxygen, or the one that's going to cause a switch during that reaction. Okay, so because carbon is more reactive than lead, carbon takes that oxygen, leaving lead in its pure form. Okay, so the addition of oxygen to a substance is called oxidation. So carbon has been oxidized in this reaction. And that's why it's important to memorize the reactivity series, because you will be required to look at an equation and know what is more reactive. So that way you can tell whether something needs to be, whether a metal needs to be removed through electrolysis or through reduction. Okay, so which metals does carbon reduce? A metal can be reduced by carbon if only it is less reactive than carbon. And so if it appears below carbon in the reactivity series. Certain metals like iron can be only reduced using carbon if they are heated to very high temperatures. If a metal is more reactive than carbon, then other chemical reactions and processes have to be used. So using the reactivity series, can you name a metal that cannot be extracted from its ore using carbon? Okay, so if you're looking at that list, it's going to be anything above carbon. So aluminum, magnesium, calcium, sodium, and potassium cannot be extracted using carbon because they are more reactive than carbon, meaning carbon's not going to be able to steal that oxygen from them. Okay, so if that happens, then electrolysis needs to be used. Electrolysis is a process that uses electricity to separate elements in a compound. And the word electrolysis literally means splitting with electricity, right? Lysis means to split, and then electro is electricity, so electrolysis. And it's expensive, so it is only used to extract reactive metals that cannot be extracted in other ways that are extremely valuable to us. And an example of this would be in aluminum. We use aluminum a lot, and it is a reactive metal, and it's found in the ore bauxite. Again, this is an ore that you have to know. You have to know that aluminum's ore is bauxite. Cambridge usually asks about this one. So it is combined with oxygen as aluminum oxide, and electrolysis has to be used to remove the oxygen and extract the aluminum, which means that reduction takes place. So what is the word equation for the extraction of aluminum? It would be aluminum oxide, okay, decomposes to aluminum plus oxygen. And this is the process. This process occurs through electrolysis. So let's look at how electrolysis works. I love electrolysis. I think it's so cool, and it's a really interesting process, and it's really you guys are going to be able to do this in lab and really see how it works. So what you see before you is a model of an electrolytic cell, and it's important that you know that term. So the whole process, you see the cell up there, you see the inner electrodes, the anode and the cathode, plus the molten electrolyte that's inside there. All of that is contained in an electrolytic cell. Okay, so if you look, the anode is taken to be positive and the cathode is negative. Okay, however, the reaction is still similar, whereby electrons from the anode will flow to the positive terminal of the battery, and electrons from the battery flow to the cathode. Okay, so if you see here in the cell, and if you're thinking about it like a circuit, you're going to see that electrons are going to be attracted from the anode to the positive terminal of the battery, okay, and that electrons from the battery are going to flow to the cathode. Okay, so electrons are flowing to the cathode. So how, and you know, this is a circuit. How is this a circuit? You can't see, there's not a wire between the cathode and the anode. So really the answer is that you have molten NaCl in this particular electrolytic cell. And remember that that's an electrolyte. And molten NaCl, and along with other electrolytes, will conduct electricity. Okay, so that's how this is actually a circuit, because electrons are able to move through that molten electrolyte. Okay. Okay, so copper is, and we're going to talk more about it. Copper is an excellent conductor, and it does not corrode quickly. So these properties make it a really good material for wiring and plumbing. Okay, we use it a ton. Only pure copper can be used for electric wires, though. Even a very low level of impurities will reduce its conductivity. So copper is not very reactive and can occur native, but it's pretty rare at this point to find pure copper. Usually it's found combined with other elements, which its ore in this case is malachite. Malachite is a green rock with lots of lighter green swirls. It's beautiful. Okay, and again, this ore you have to know. Okay, the copper extracted from compounds by reduction with carbon is impure. So electrolysis can actually be used at this stage to remove the impurities and obtain pure copper. And this is like a very typical Cambridge question. Copper is less reactive than carbon. So you can use reduction to extract copper from its ore, but the copper that is extracted is impure. So electrolysis is used as a step to really get the pure copper from that ore. Okay, so looking at this model, so here's your electrolytic cell. There's your electricity supply up here. You can see the positive anode, and you can see the negative cathode. So we know that copper has a positive charge. And so when you put in this anode, okay, it's this positively charged anode, it is covered in copper. Okay, so it's coated in copper, but the copper is impure. So when you put it inside this electrolytic cell and you have a molten material that is a electrolyte, over time those copper atoms are those ions, copper ions, okay, the 2+ copper ions are going to start migrating over to that negative charged cathode. Okay, and so it depends on how much electricity and the level of the copper, but over time you will have pure copper that has migrated over to that cathode, and left at the anode you're going to have the impurities that were originally in that copper. Okay, and it's often called anode sludge. Okay. Okay. All right. Environmental impacts of mining. Open cast mining removes ores using explosives, and it produces dust and can scar the landscape. This disused copper mine in Ajo, Arizona measures 1 mile wide. Extracting metals causes a huge amount of waste. Copper production discards 99.5% of the extracted ore. And in the process, harmful waste gases, including sulfur dioxide, carbon dioxide, and carbon monoxide, are produced by the extraction. And especially electrolysis, the process of extraction uses a lot of electricity. New mining techniques can decrease the effects of metal extraction on the environment. So one of these is leaching. This uses electricity or uses less electricity than traditional mining. It does not produce waste gases. Copper ores are treated with and dissolved in dilute sulfuric acid, which produces copper sulfate. And then electrolysis is used to extract the copper from that. And certain bacteria can also be used to dissolve ores and form copper sulfate. So also phytomining. So this uses plants to absorb metals from the soil, and the process can be used to clean contaminated land. Treating the plants with certain chemicals increases their ability to accumulate metals and minerals in their cells. Okay, so metals are easier to recycle than plastic because they contain their original properties after recycled, like conductivity and hardness. Recycling uses up to 95% less electricity than producing metals from ores. So, recycling metal that's already been used by something, then you don't have to extract it from its ore. You're just melting it down and reusing it, which is a lot more profitable. Okay, recycling creates less waste and reduces the number of sites that have to be mined. But one problem is that metallic materials and recycled objects are often mixtures of different metals. And this can mean that obtaining pure metals from recycling is more expensive, as it may use more electricity than extracting metals from ores. Okay, so there you are with some reactivities. So I hope you enjoyed this lecture.